Okay, prime numbers are numbers that have only two factors, okay? The number 1 and the number itself. Example of the first few prime numbers is 2, 3, 5, 7, 11, 13, 17, 19. Okay, all those numbers only have two factors. When we talk about factors, what we're talking about is a factor times a factor equals a product. Okay, so a product then would be, for example, 3 times 5 is equal to 15. Okay, so that's what we're talking about when we talk about having a factor. Trying to expand it here. Let me expand it. Okay, so that's what prime numbers are. Okay, the factors of, for example, the factors of 3. Okay, the factors of 3 are 1 and 3. In other words, that's the only thing you can multiply together to get 3. 1 is not prime. Okay, 1 is not prime, but it's also not going to be composite when we talk about composite. Okay, 1 only has one factor. All right, now let's go ahead and talk about the definition of composite. Composite numbers are numbers that have more than two factors. Okay, composite numbers are numbers that have more than two factors. Okay, obviously there's a whole host of these that you start with 4. Okay, you have 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, just keeps on going. Okay, but they're numbers that have more than two factors. For example, the number 15. Number 15 has 1, 3, 5, and 15 as its factors. Okay, and so therefore it has to be composite because it has more than two factors. If it only has two factors, then it's prime. If it has more than two factors, then it's composite. Okay, now, for example, if we have 20, okay, what are the factors of 20? So we have 1, 2, 4, 5, 10, and 20. Okay, so those are the factors of 20. Okay, now, let's take a little detour here and let's make sure that we remember, because these will come into play, our rules for divisibility. Remember, we learned these last year. The rules for divisibility are shortcuts. Okay, these are shortcuts. For example, 2 goes into a number if the number is even. Okay, 3 goes into a number if you add the digits together and it is a multiple of 3. Okay, in other words, 123. 123, if we take 1 plus 2 plus 3, okay, let me put this down here. You have 123. Well, if we take 1 plus 2 plus 3, that's going to equal 1 plus 2 is 3, plus 3 more would be 6. Okay? So, 6 is a multiple of 3, so 3 goes into 123. Okay, so that's the rule for 3. Okay, the rule for 4, if the last 2 digits of the number is a multiple of 4, then 4 goes into the number. Okay, for example, $2,348. Okay, well, if we look at the 4/8, if you look at the last 2 digits, 48, then 4 goes into 48.
Good morning, everyone. I just want to remind you that there are T-shirts on sale in the office for $12, and they can be worn tomorrow with your jeans for Spirit Day. I also want to remind you that we have glow sticks and necklaces and bracelets that you can wear at the Lights Out Pep Rally. And the more glow we have, the more effective the pep rally. So we're asking that you consider purchasing those as soon as possible so that you can have those for tomorrow. And the pep rally will begin at 3. The pep rally will begin at 3 tomorrow, and teachers will escort you down, and we're going to have a good time, and we're going to have a good homecoming. God bless.
Okay, for 10. For the number 10, if the number ends in 0, okay, why it shrunk my 10 down there, I don't really know, but it did. And then the last one is 9. Okay? 9, the rule for it, if you add up the digits and it is a multiple of 9, then 9 goes into the number. All right, now, those are just, obviously, like I said, we had those last year, but I wanted to remind you of them because they're very helpful. Okay? When you're dealing with factors, sometimes it's hard to get all the factors without knowing some shortcuts to it. Okay, so here's what I want you to do. I want you to take the number 54, okay, I want you to take the number 54 and prime factor it. And list all the factors, okay? List all the factors of 54. Do that quickly, and let's see if we can get them all listed. All right, who has the factors? Let's see, Derek.
1, 2, 3, 6, 9, 10.
What?
1,
No, that's some of them. Annie. What was after 18? Yeah. It is 1, 2, 3, 6, 9, 18, 27, and 54. Okay. It's always best to try to list them in their pairs, 1, 54, 2, 27, 3, 18, 6, 9. Okay? So those are the factors. So that brings us to our next part, which is prime factorization. Everybody's favorite. Right? Everybody loves prime factorization? Do what? Yeah, I know, isn't it? All right. It's better than money, huh? It's better than $1 million. All right. Prime factorization, okay, is the product of the prime factors of a given number. Okay? There's two ways to prime factor. Okay? First way is to factor tree. Okay? Factor tree, you're listing factors of the number. Both composite and prime. Okay? Number 2 is inverted division. In inverted division, you're dividing the number by only prime numbers. Okay? So, let's look at those two. For example, let's say I'm going to prime factor 68. Okay, I'm going to prime factor 68. So factor tree would look like this. And once again, I don't care which one you use. If you want to use both of them, that's fine. Okay? 68 would be, I want two factors of 68. What's two factors that you multiply together to get 68? What? 4 and what? 4 and 8?
No, 4 and 6. I mean
8
8 and 6.
and 6. No, 8 and 6 would be 48, not 68. 2 and 34. Okay? So, is 2 prime?
Yes.
So I circle it. So, what's two factors of 34? 17 and 2. That's prime, that's prime. So, the prime factorization is not the factor tree. The prime factorization is 2 to the second times 17. That is the prime factorization, not the factor tree or the inverted division. Okay? Now, if we do the same thing with inverted division, okay, the same thing with inverted division means this. We take 68 and I invert a division bar. Okay? Then I just use prime numbers. First few prime numbers, once again, are 2, 3, 5, 7, 11, 13. So I just divide by 2 because 2 goes into it because it's even. 2 goes into it 34 times. Does 2 go into 34? Yes. So I divide it into it. It's 17 prime. So I'm done. 2 to the second times 17. Okay? So either way, you're going to get the correct answer if you do the math right. The reason I am a bigger proponent of inverted division is because when you get to numbers like this, 588, and you're going to do the factor tree, well, you're going to do exactly what Matt Haygood just did. You're going to take 2, and you're going to go 2 times this is 2 times whatever is 588, instead of coming up with 2 other factors. Well, if you're going to do that, you might as well just take 588, stick it in the inverted division, and go 2 goes into that, 92, 94. Okay, because 2 goes into 5 2 times, remainder 1. 2 goes into 18 9 times, remainder 0. 2 goes into 8 4 times. Then you got 2. That's 1, 4, 7. Okay, here's where most of you would go, well, that's 147's prime. No, what's 1 plus 4? Plus 7. Does 3 go into 12? Then 3 goes into that number. 3 is prime, so I divide by 3. That would be 3 goes into 14 4 times with the remainder of 2. 3 goes into 27 9 times. Now, 7 and 7. So that's 2 to the second times 3 times 7 to the second. Nicole? Huh? It's Mark, but yeah. All right, now, I don't care. Like I said, you can use both ways. If you like the factor tree on the smaller numbers, you can use the factor tree on the smaller numbers. If you want to use the inverted division on the bigger numbers, then use it on the bigger numbers. Okay? If you had 2 factors here, something you might come up with would be, 12 times 49. Okay? Well, that goes to 7 and 7. That goes to 6 and 2. That goes to 2 and 3. Okay? Well, that was easy if you knew 12 and 49. But if you sat there for 10 minutes trying to figure out 12 and 49, you're better off just using inverted division. Now, remember, in inverted division, out here, okay, those can only be prime numbers. Okay? You can't take and divide, on the outside of one of those inverted divisions, say 12. 12 is not a prime number. Okay, so you can't do that. So I want you to prime factor 612. Prime factor 612. And remember, your prime factorization is the multiplication at the end.